So next third instruction, that is the push and pop instructions. So you might be heard in the last semester also, push and pop, they are related to the stack memory. So you can observe here, here we are using the stack, here one more, here this side stack, here I am showing the internal RAM here. So here for example, here it performs the increment SP plus 1, SP plus 2. If I take some variable like this, is if it is X here, I am pushing the X here, so this is Y. So similarly here also it is the pop Y, pop X. So that means before going to make explanation for this one more thing we need to understand here. So here stack is nothing but this is the memory unit, or we can say it is a part of the RAM also. You can see here, if I consider this is the memory location, this is the stack register, this is the space stack memory. So it is also going to store the data here. For example, here it is going to store the X, Y, Z. Some of the datas are there. Is it clear? So that means completely I can say this is the stack memory. So here I am using the SP. This is actually the stack pointer. So this one is the stack pointer. Stack pointer is nothing but it is always going to help, keep or always going to point out the top of the address. That is nothing but whichever the data is there in the top in the entire list, it is going to represent the top of the address. That is nothing but if you are consider this is the stack memory, what is the address of the stack pointer? In the sense it is going to hold the address of the only the Z variable. Whatever the address is there, it is going to keep. Otherwise you can see one more example here, only the two data I am going to store here, X and Y. What is the address of the stack pointer? Is nothing but what are the top of the value here, data Y itself. That is nothing but this is the top of the address of the stack. For example, if I consider only the X variable, X data here, so top of the address itself, top of the stack address itself, this is the X only. So that means which data will be the available in the topmost here, that itself the top address of the stack only. It is going to represent with the help of the stack pointer. Stack memory unit, stack pointer, it is going to point on to the top of the address which is held by the stack. That is two things you need to remember, stack and one more the stack pointer. Stack pointer in the sense this is a special function register. So here you can check this example here. So this is related to the push operation, this is related to the pop operations. So that means when you are going to speak about the stack, we need to explain the two instructions, that is the push and the pop. These are also the data transfer instructions. Push is nothing but we can say it is something like the insertion of elements to the RAM location, internal RAM. This is push is nothing but this is insertion operation. Pop in the sense this is the deletion of operation. This is pop is exactly reverse of the pushing here. And also one more thing you need to understand, when you performing the pushing operation, first it will perform the increment operation. In the pop operation, here first it will perform the pop, then later it will perform the decrement here. So in the one more thing you need to understand, pushing is the sense it is keep on adding the elements to the RAM locations. So that is nothing but what will happen if you perform the pushing continuously, the size of the RAM it becomes the keep on increase this side. In the sense what we can say, pushing with respect to the increment operations. Pop in the sense what will happen, this is the deletion of the element from here to the here. That means we can say this deletion in the sense we can say this is the decrement operation by the pop here. So here what will happen, if I want to push this X, some X data is there here, Y data is there. If I want to push the X data to the RAM here, first it will perform the increment operation. So that means SP, it becomes stack pointer, basically default value SP is there. SP plus 1 means this is the X. If you want to push the Y variable at the time, first it will perform the increment. That means previously SP plus 1 is there. If you make it plus 1 means it becomes SP plus 2. So this is helps to push the Y variable here. Once you perform the pushing for the X variable and Y variable, same data is available in internal RAM X and Y. And second thing what will happen, just I done the pushing operation. Second thing what will happen, mainly stack it perform the LIPO in the sense list last in first out. So just you see here, it will mainly perform with the help of the LIPO. LIPO in the sense this is the last in first out. So last in means which is the last data entries in this table. So last entry in the sense y is there, last entry. So that means this last entry y, it will goes first out. So this is the first out, this is the last in. So last in y is there. So when you are performing the pop operation, for last input, it has to come out first. So in the pop, what will happen? First I need to make the pop y, then later I need to make the pop x. So what will happen? This is exactly reverse of the pushing operation. So just to try to understand the push and pop and what is the stack and what is the stack pointer. Again in depth we are going to discuss in the third module. But just try to understand this small diagram, that's it. So already you know that data transfer is nothing but it like a source to the destination side. So that means when you are performing the pushing operation, it will something like it transferring the data to source to the RAM location. Pop operation in the sense from what will happen from the internal RAM, it will retrieve the data towards the destination side. So that means what I can say here, this is your act like it is a source, it is act like the destination part. So in between it will temporarily it will act by the internal RAM. So that means the source it will comes to the here, and again the same data it is going to retrieve or it is going to send towards the destination side. So you can see here stack pointer already I said in the diagram. This is a special function register which helps to point out the address location of top of the stack. So you see the some example of mnemonic. So just we need to write the push add. No, don't write the something like destination and source here. Only we need to add this particularly what is the where you want to push or where you want to pop it. For example here push space add, that is nothing but first it for pushing operation already said first it performs decrement operation. That means increment the stack here, stack pointer, then copy the data in add. That means whatever the data is there in the add, it is going to copy to the internal RAM. So that address is contained itself in the stack pointer. So that means whatever the address is held by the stack pointer, is it clear? Same data is going to transfer to that particular address. So it is going to perform the increment operation. Similarly, pop space add in the sense this is a reverse of this one. So here what will happen, copy the data from the internal RAM address contained in the SP. So that means whatever the address was there previously here, so from that respective address it is going to copy the data to the add here. So this is later it perform the decrement the stack pointer. This that is nothing but pop is exactly reverse of the push operation. So here also already I said when you performing the pushing operation, it is going to keep on increase the size of the stack, but finally it has to have the one end should be there. That end we can say this is the 7FH. If you try to store the some data beyond the 7FH, it is going to give the error or those respective data is going to get vanish. So that is nothing but up to the value of 7FH only we can load the values. So this is the last value of the stack, that is the 7FH. So that means here just to try to understand what is the stack pointer and what is the instruction push and pop. Is it clear? In depth we are going to study about in the third module. Go. So last one is the XCH. XCH stand for the exchange. So exchange is nothing but general meaning of exchange is nothing but mutually we exchange the data. So here what will happen, it will support all the type of the addressing mode except only the immediate only. So just to see the some examples, same mnemonics here. XCH A comma XCH with the sum of the R register, anyone you can use it. Here what will happen, whatever the data is there in the register here, it is going to send to the accumulator, and whatever the data is there here, it is going to exchange to the this register. That means we can see the some example. If the accumulator value is the 7 here, in register value is something like 8 here. So this register 8 is going to exchange to the accumulator here. This 6 is coming to the this side. That is meaning of the exchange here. So some example you can see here. XCH A comma add XCH A comma at RP. So this is the indirect register addressing mode. RP pointer register, only you need to use the R0 and R1. So that means whatever the data is held by the R0 or R1, it is going to exchange to the A. Similarly A to the RP. So one need to understand, don't get confused with the one more is the swap. swap is different and exchange is different, because swap is only going to operate for only the accumulator content or only the accumulator register only, but exchange is nothing but it is going to operate with the two operand, or it may be the two things here. So that means instead of using accumulator here, XCH is going to use the two registers. Don't get confused, these two, these are different with internal operations. All exchanges are the internal to the 8051. These exchange operations entirely the operate with only the internal things. And also, if you see the all the instructions here, examples here, accumulator is common. That means all exchanges are use the register A only. And check the last one, I written the XCHD. So in XCHD instruction, what it does here, it is helps to exchange the lower nibble. So lower, already I said lower nibble and the upper nibble. So that means only the lower nibble is to make the exchange by keeping the higher nibble as it is. So that means I written here, just read it once. When using the XCHD, upper nibble of A and upper nibble of the address location in RP, it doesn't change. So that means upper nibbles it is going to keep as it is. It is not going to make any changes. But only thing is only the lower nibble it is going to get exchanged by using the only XCHD instruction. Remaining are only the XCH instruction. So this is very important in the lab purpose, and try to read all the instructions and try to make it a practice.